In titration analysis, titration curve is a core element of the analytical method. In this lesson, we will study the formation and production of complexometric titration curve, the titration jump range and factors affecting the jump. With addition of complex integrand, the metal ion is constantly complex and its concentration decreases. Log m is denoted as Pm. Log m prime is expressed as Pm prime when the side reaction occurs. When titration reaches the end point, Pm or Pm prime changes dramatically. Plot of Pm or Pm prime versus the added amount of titrant is called the titration curve. The jump range and the change rule of m or m prime at the stoichiometric point can be obtained from the titration curve. For complex metric titration, the analytical concentration of M is expressed as Cm, and the volume of solution is expressed with Vm. When the EDTA standard solution with the same concentration Cy is used for titration, the volume is denoted as Vy. According to the complexation equilibrium and mass balance, and considering the possible side reactions, the conditions of log K prime My near the endpoint can be discussed with the omittance of side reactions of My. Log K prime My less than 10 indicates that the stability of the complex is not good. The Pm prime near the stoichiometric point is calculated according to the Regulus formula. When log K prime My is greater than 10, the stability of the complex is good, and the calculation of Pm prime near the stoichiometric point can be simplified. Take the titration of 20 microliter zinc ion with 0.02 mol per liter EDTA at the same concentration as example. The titration conditions are as follows. The titration is carried out in the buffer solution of pH 9, and the analytical concentration of ammonia is 0.02 mol per liter. Then the analytical concentration of ammonia near the stoichiometric point is 0.01 mol per liter. The log K prime My can be calculated as following. Now the dissociation of zinc Y can be neglected. There is side reaction, so with addition of titrant, the titration process can be divided into 4 stages. The first stage, before titration, P zinc depends on the analytical concentration of zinc in solution. The second stage, that is slightly before the SP, P zinc prime is determined by zinc prime which is not titrated, supposing Vy equal to 19.98 microliter. In the third stage, at the SP, titration reaction is completed accordant with the stoichiometric relationship. Zinc prime in solution is from the dissociation of zinc Y, and the calculation of zinc prime is as follows. The result shows that at the SP, concentration of zinc which doesn't react with is less than 10 to the negative 6 mol per liter, indicating that the titration reaction is complete. In the fourth stage, after the SP, excessive EDTA inhibits the dissociation of zinc Y, and the P zinc prime in solution is related to excessive EDTA. Assumed the added EDTA volume at the time is Vy equal to 20.02 microliter. According to the expressions of zinc Y, Y prime and K prime zinc Y, zinc prime and P zinc prime expressions are obtained. Thus P zinc prime equal to 7.12. In the titration of zinc with EDTA, the change of P zinc prime with added EDTA volume is listed in the table below. Applied P zinc prime versus the titration fraction, and the titration curve of zinc is obtained. Before and after the SP, the relative area of the volume is within the range of plus or minus 0.01%. The jump range of delta Pm prime is 5 to 7.12. The following are the main factors that affect the titration jump. Factor 1 is the solution pH. The larger the pH, the larger the jump range is. The lower the pH, the smaller the jump range is. The solution acidity can be controlled by buffer solution. Factor 2 is K'my. The larger the K'my, the wider the jump range, and K'my and Kmy are affected by alpha 1 and alpha m. For metal ions M with small Kmy, titration is performed at low acidity to reduce the influence of acid effect. Too low acidity can cause the hydrolysis of M. In order to prevent hydrolysis and coexisting ion interference, auxiliary complexing agent and masking agent must be added, but the complexing effect of added reagents should also be considered. Therefore, it is necessary to balance the impact of both. Factor 3 is the concentration of titration metal ion Cm. When K'my is fixed, the lower Cm the high starting point of Pm' is, and the smaller titration range is. Through this lesson, we should know how to produce the titration curve of complex matrix titration, as well as the factors affecting the curve.